Hi kids, we'll be going with this cube thing again. I'll be just saying the same thing what we have done before, but a slight extension of it. So if you want to find the equivalent resistance between these 2 points, we have done using 2 ways before. Now I am going to explain the same thing. It's like if the battery is giving current I, it will be taking current I back. So you can visualize that part like this. Battery is going to give current I and it is going to take the current I back. How I will be visualizing this thing is, I will be visualizing this as superposition of these two figures, where I will be giving 7I by 8 from here and I will be taking I by 8 from every other corner. So that incoming current equals to outgoing current. Now similarly here, I will be taking 7I by 8 and giving I by 8 from the other corner, such that incoming current equals to outgoing current. Now when I superimpose these two, all these I by 8s will be getting cancelled. I by 8 plus 7I by 8 will turn out to be I, and I by 8 plus 7I by 8 will turn out to be I. So that's the idea. When I superimpose these two, I will be getting this thing. Now understand one thing, this superposition is going to work only because of V equals to IR is linear relation. Now I will be going a step ahead. Now for this guy, all these 3 paths are similar to each other. You don't find any difference. So this current will be splitting into 3 equal parts, 7I by 24, 7I by 24, 7I by 24. Similarly here, these 3 are equal parts, 7I by 24, 7I by 24, 7I by 24. Now I am going even one step. Okay, fine. I think that's in the next figure. So this is what we have done before also. So when you superimpose these two figures, then the current in this one is 7I by 12. Because current in this one, you know, when you superimpose, you will be getting 7I by 12. But while doing this, I didn't draw what are the currents in the remaining parts because I didn't find it here. I found only current in this part here, but I didn't find what is the current in this part. Anyway, so by this method we understood current is 7I by 12. So when you write loop equation, you will be getting this much. So voltage of the battery by current given by the battery will give us effective resistance. So we found effective resistance. This we have already done. But while doing this, in this figure we have written only this current. Now what I am going to do, I am going to extend it and I am going to find all the currents in this based on these two figures. So let me start it here. So again the same thing, I am doing the same thing. I am giving 7I by 8, taking I by 8 from everywhere. I am taking 7I by 8 and giving I by 8 from everywhere. When I superimpose, I will be getting this thing. Now yeah, so you pay attention. It's like I have already explained this will be splitting into 3 parts because these 3 are equal paths. Now now you can see these 3 are equal paths. So this potential and this potential will be same. Now look at here, this potential is same. They are going to give current to this guy. Now this potential is same. So this potential difference and this potential difference is same. So current in this one and current this one has to be same. Now out of 7I by 24, yeah, now similarly I can prove like, okay, I didn't draw it here. Yeah, I should be drawing it here also. So I can prove like this current will be splitting into 2 parts the same way, right? So this current and this current should be same. Similarly, this current and this current should be same. Similarly, yeah. So I can prove like all this red color thing should be same. Now out of 7I by 24, I by 8 is going this way, I by 8 is going this way. Then out of the remaining, half will go this way, half will go this way. When you do that calculation, it will turn out to be I by 12, I by 12. Now similarly, I by 12, I by 12, I by 12 and I by 12. Out of 7I by 24, I by 8 is going this way, remaining will split into 2 parts and they go like this. Now here, this is I by 12, this is I by 12. So I by 6 is entering. Out of I by 6, I by 8 is going this way, remaining will be I by 24. Similarly, I can get I by 25, I by 24. Now, no matter what is the cube, the currents will be only these 3 currents, 7I by 24, I by 12 and I by 24. Now I can do the same thing here. So adjacent ones will be 7I by 24. Then the rest connecting will be I by 12. And the last 3 will be I by 24. Now when I superimpose these two, then current in this guy is going to be 7I by 12, current in this guy is going to be 7I by 24 minus I by 12, that is 5I by 24. Similarly in this one, 5I by 24. Now these two superposition, I will be getting I by 24. Now this one, I by 12 plus I by 12, I by 6. So similarly, I can find currents in all the ones by superposition. So it is going to look like this. All the currents are going to look like this, which is not needed to calculate equivalent resistance here. Now, but why we are doing this is, yeah, this is how it is going to look. Now, maybe sometimes I might have done some calculation mistake, mostly no. you can cross check like KCL is getting valid or not. The same idea we are going to use it here. This is a simple cube question when we do symmetry. So equivalent resistance between these 2 points, I will be giving current I and I will be taking current I from here. Basic battery will be giving I and taking I. So the figure is going to look like this. When you connect a battery between these 2 points, what is the equivalent resistance? And these currents we have drawn by ourselves when we are doing a symmetry question. Now we are going to do it in this manner. So I am going to visualize this figure as superposition of these two figures, where I am giving 7I/8 and taking I/8 from every other corner, and I am taking 7I/8 and giving I/8 from every other corner. When I superimpose these two, I will be getting this figure. That is the idea. Now again the same thing. When I am giving 7I/8, these currents will be 7I/24, the rest over will be I/12, and the last 3 will be I/24. Now similarly, first 3 will be 7I/24 and the last 3 are going to be I/24, remaining will be I/12. So when you superimpose these, then 7I/24 plus I/24, 8I/24, so you will be getting I/3, again I/3, again I/3. Now similarly, if you superimpose those red color things, you will be getting I/6, again when you superimpose those pink color things, you will be getting I/3. Now this we already know. So when I draw this figure, when I put this figure here clearly, then you can see, because we have already predicted by symmetry, it will be splitting into 3 equal parts. If this I/3, if these are I/3, then this also will be I/3 and this will be I/6, which we have done in a much simpler way. Now if I want to find the equivalent resistance, I will be writing the loop equation along this loop. Then I will be getting this equation, EMF of the battery by current, I mean V by I. V by I is going to give us equivalent resistance, right? Now similarly, I will be finding the equivalent resistance between these 2 points also. Basically battery is connected like this. Now again I will be doing the same thing. I will be visualizing this as superposition of 2 things, where I will be giving 7I/8 from here and taking I/8 from everywhere, and I will be taking 7I/8 from here and giving I/8 everywhere. When I superimpose these 2 figures, I will be getting this figure. Again this one we have already seen, 7I/24, remaining I/12 and remaining I/24. Now in the same way, if this is 7I/8, these adjacent ones will be 7I/24, 7I/24, then the next attached ones will be I/12, and the last corner is going to be I/24, right? Now I need to superpose these 2 figures. When I superpose these 2 figures, 7I/24, I/12, you will be getting 3I/8. Similarly, this one you can superimpose, you will be getting these currents. Let me look at this one, I/12, 7I/, I think it's the same thing, right? Now if you look at this one, I/12, if you do this, then no current will be flowing through this. I think I didn't write some things here. Probably you can write by yourself. Okay, I didn't write every current, so probably you can write every current by yourself. I have written only some. So the idea is superposing those 2 figures. When I superpose those 2 figures, I will be getting some currents like this. But I didn't write the remaining because I want to write loop equation. So when I write the loop equation across this one, I will be getting V minus IR equals to 0. So from there I will be getting equivalent resistance is 3/4R, right? So this one, how it all started, we started from here. We learned symmetry, then we went with this cube, and in this cube it is highly symmetrical, so we said all these 3 currents are equal and we did it. So while doing that sequence, the last question what we did was this thing, by symmetry. After that we started seeing this as superposition of these 2 things. Then once we understood superposition of these 2 things, then we started applying it to the easiest one what we have done, that is this one. After that we have applied for the other cube also. Other cube is this cube. Then you can apply the same thing for infinite grid and stuff, right? Thank you.